Hi, we're Project Additie. Our sponsor is Lockheed Martin, and I'm Drew Craven, our faculty contact. We also have Spencer Scarber, our captain and sponsor contact, and Alexandra Light, our secretary. Our faculty advisor was Madi Naruzzi.
The scope of our project ranged a lot of different ASTM standards. We were hoping to obtain different information about the material properties of this 3D printed material. So we were aiming to complete linear thermal expansion testing, transition temperatures of fusion and crystallization, shear properties, tensile properties, compressive properties, different open holds, compression and tension as well, to cover all of the bases of different manufacturing and different geometries that could be used. We also looked into bearing responses and flexural properties. And then outside of the ASTM range, we wanted to look at the photomicrographs of the printing material just to see the sort of resolution we were getting, as well as any sort of inconsistencies that could be seen. We also aimed to do fluid resistance and UV light. Fluid resistance, just a submersion in different substances to see what kind of a reaction the material could have, as well as UV light exposure. Since the resin is cured with UV light, we wanted to explore the possibility of what could happen if that resin was exposed to UV light for longer than needed to be for just purely curing cases.
So the first test I'll go over is ASTM E228, which is linear thermal expansion. We contracted this out to Rogers, who used a thermomechanical analyzer to measure the deflection of a workpiece when exposed to a temperature range, which was metered by a thermocouple. So this helped us determine the linear coefficient of thermal expansion and capture heat deformation curves to see how the material would react under high temperature loads and seeing a deflection and stress induced by those processes.
We also contracted out Dsc Testing, differential scanning calorimetry. We did not have the materials for this test, so we had them run the tests with their machinery. They obtained transition temperatures as well as the first order and glass transitions, and they sent over a graph that will go over all of the different temperatures, as you can see here, as well as the heat flow, just as a comparison to see those different transitions. We also explored shear properties. We ran ASTM 5379, which is a V-notch beam shear test with a strain gauge in the center to just explore what kind of strain that was experiencing. We obtained the shear strength, or the shear stress and ultimate strength, the shear strain and ultimate strain, the modulus of elasticity, and as well as the chord modulus and the offset shear strain. So we obtained that stress strain curve.
Next were the tensile properties, which is ASTM D576. This is where we got the bulk of our mechanical properties of the material. Obtained information was load extension curves, tensile strength and stress, percent elongation, normal strain, and modulus of elasticity. This testing was conducted on the Instron in the materials lab at Grand Valley State University. And we used wedge grips to fasten the specimen between the load cell and the stationary base. No yield behavior was observed, only break at rupture. So yield calculations were voided, and break was what provided us most of the data, indicating that we had a brittle material. Next up was ASTM 695, which is compressive properties. This is similarly used on the Instron, but instead of the wedge grips, compression platens were used to measure the load deformation curves, compressive strength, compressive yield strength, and offset yield strength. Again, no observable yield strength was easily definable on the load deformation curves or stress strain curves. And so offset yield strength was a useful approximation method to find the yield strength on those stress strain curves.
ASTM D576 covered the open hole tensile strength. Given that the end-use application of some of these 3D printed parts might be antennas that are integrated into the body of an aircraft, it's important to test the strength of holes through which they might be fastened. Through this testing, we determined the ultimate strength and failure mode of each specimen that was tested. And in the same vein, ASTM 5961 covered the bearing response. So it simulated pull-out strength of a fastener if the antenna or end-use product were fastened using a bolt of some sort. And the information obtained from this was the bearing stress and bearing strain response, ultimate bearing strength, bearing strain at failure, and the failure modes and locations. Turns out that the material is very brittle, as Drew mentioned, so we didn't really see much yielding. Rather, it was an abrupt break for many of the pieces. And open hole compression, yet again, following the same vein of testing, this was governed by ASTM D6484, and the ultimate open hole compressive strength and failure modes were determined.
3-point bending, ASTM 790 was then completed. This was a basic 3-point bending test completed on the Instron, where the piece was balanced on the piece and a point was brought down from the top. The flexural stress and strain, as well as the chord modulus, was then determined for these flexural properties. The photomicrograph analysis was a interesting test to look at. We were able to see a lot of the differences when it came to layers and the different crystallization of the resin. It was difficult to see the dispersion consistency of the layers since it was difficult to break across purely a layer. We were able to get some pictures of them from the first and the final layer, and then we were able to also observe the cross section in order to see the consistency of those layers. So we were able to extrapolate some sort of a consistency throughout the material, but we're not able to directly observe that consistency per layer.
On the end-use product, the antenna or whatever product will most likely be exposed to a variety of fluids, given that it's going to be used in a military application. So these are a couple of the fluids that were chosen, and we would be submerging the pieces in these fluids for the prescribed duration of time, and then conducting tensile testing via ASTM D638 following their submersion. And in addition to the fluid testing, Alex earlier mentioned UV exposure. Because these parts were cured using UV light, it was important to investigate how the material degraded if they were exposed to UV light for a long duration of time. Now, in order to simulate this, we were planning on using a UV light at around 30, 60, and 90 days. And instead of exposing the parts to the direct sunlight for 30 and 60 and 90 days respectively, we chose to use a UV lamp. So the natural light exposure for 30 days is 720 hours, but that could be achieved by an artificial exposure equivalent of 24 hours via the UV light. So that same process is repeated for the 30, 60, and 90-day periods.
Our budgeting for this project was a little bit loose, considering we didn't know the price of the specimens printings, considering the printer wasn't set up until the very beginning of our project. So we were able to stay around the budget that we were given, and it was about $22,000 for the specimen, different orientations, different testing tickets. There were a lot of different pieces in this. The apparatus pricing for the specific ASTM compliant fixtures in order to run those ASTM tests without worrying about different tolerances or making sure that our machinability was absolutely perfect for the standard. We also obtained different materials for the UV testing, fluid testing, about $1,000, and miscellaneous costs for different things like safety equipment or other consumables was also included in this budget.
For the forward-moving action items, at the conclusion, so since we're at the conclusion of the project, it's important to note that some of the procedures and tests were omitted due to unfortunate events that were outside of the control of the senior project team. So some of the procedures that were omitted were the open hole compressive strength, most of the fluid resistance fluids, and UV resistance was also taken off the list of tests that were to be performed. The sponsor was okay with that, and the project continued on accordingly. That's where we're at.
That's our presentation. Thank you very much, and please ask any questions at this time. Thank you.